Okay, today we are going to learn about the production possibility frontier, which is basically a graph that shows the potential output possibilities of two different goods produced using factor inputs being land, labor, capital. Okay, so with this graph, we are going to illustrate the concepts of trade-off, opportunity cost, economic growth, and efficiency. Okay, so the most common example, okay, is a country can produce different combinations of guns and butter given their factor input of labor. Okay, so we are going to say that 1 hour of labor produces 10 pounds of butter or 5 guns. The nation is the U.S., and the U.S. has 100,000 hours of labor. Okay, so with our labor hours, we can produce all guns and no butter. In this case, okay, remember that 1 labor hour, okay, produces 10 pounds of butter or 5 guns. Okay, so here, if we use all our labor hours, okay, to produce guns, then we can produce 500,000 guns, okay, and that's the 100,000 labor hours times 5, okay, and since we used all the labor hours for guns, we have none left over for butter, all right. Let's say we use 75,000 labor hours for guns and 25,000 for butter. Okay, so 75,000 labor hours that produces, okay, for guns, and each labor hour produces 5 guns. That yields us 375,000 guns. All right, and 250,000 pounds of butter. All right, so okay, let's say we split half and half, 50,000 labor hours for guns and 50,000 labor hours for butter. All right. Okay, let's just go ahead and skip this graph. Okay, so here this is the graph, well, graphed out, okay? So we have pounds of butter on the horizontal axis, okay, and we have number of guns on the vertical axis. Okay, so if we produce all guns and no butter, then we would be up at this point here. Okay, 500,000 guns, 0 pounds of butter. Okay, if we were to produce 375,000 guns, then we would have 25,000 labor hours left over for butter, so we would produce 250,000 pounds of butter. So we would be at this point over here. Okay, and then so on as we keep on graphing our different points. This is when we are using 50,000 hours towards guns, 50,000 hours towards butter. This point is when we are using 25,000 labor hours for guns, 75,000 labor hours for butter, and then we have the final point over here where we only produce butter and no guns. All our resources, which is labor hours, is being used towards, well, it's being used towards butter. Okay, so here we see the illustration of trade-off. Okay, as we go, okay, from point A to B to C to D and to E. Okay, as we go to this point, okay, through these points. All right. We see that we are trading off, okay, guns to gain more butter. So from point A to point B, okay, we traded off 125,000 guns in order to gain 250,000 pounds of butter. Okay, because from point A we had 500,000 guns and 0 butter, and then at point B we gained 250,000 pounds of butter, but lost 125,000 guns. Okay, so we are trading off guns for butter. Okay, and then as we go from point B to point C over here, okay, we traded off an additional 125,000 guns in order to gain an additional 250,000 pounds of butter. Okay, and then so on. So as we go from point A to point B to point C to point D to point E, we are trading off more and more guns in order to gain butter. And then the reverse is true. As we go from point E to point D to point C, etc., okay, we are trading off butter in order to gain more guns. The other concept we can illustrate here is of efficiency and inefficiency. Okay, so let's say, okay, we have a point. Okay, let's label a point over here. Okay, let me get this graph a little bit cleaned up here. Okay. All right, so let's talk a little bit about efficiency and inefficiency and just plots that are not attainable. All right, so let's say we have a point right here. Okay, we can call this point F. All right, so point F, you know, is basically we are producing 250,000 guns and 250,000 pounds of butter. All right. Now, is this possible? Okay. So let's talk about it a little bit. All right. So each gun that we produce takes 5 hours of labor. So we have used a total of 50,000 hours of labor hours for guns. And then to produce 250,000 pounds of butter, we use a total of 25,000 labor hours. So we use a total of 75,000 hours of labor. So this point is possible because remember we have a total of 100,000 hours of labor to use. However, it's not efficient. Okay, efficiency is when we use all of our resources, where we get the most of our resources. And so what would be efficient is if we were using all 100,000 hours of labor. So essentially we have a little bit of unemployment going on at point F because there are 25,000 labor hours not being used. All right, let's plot another point. Okay, so we have point G here. Okay, so point G, all right, we are producing 375,000 guns. Okay, and this takes 75,000 hours of labor, and we have 500,000 pounds of butter, which takes 50,000 hours of labor. So essentially, this point would require 125,000 hours of labor. Though we would like to be at this point because, you know, we get more guns and more butter, it is not possible. Okay, it is not possible because we don't have enough labor hours. We only have 100,000 labor hours. So though we would like to be at this point, it is just not possible. Now, any point that's actually on the production possibility frontier, so, you know, any point that's on the line over here, these points are efficient because at every single one of these points, we are using all 100,000 hours of labor. Okay, and that's ideally where we would like to be, is at the most efficient point. All right. Let's also talk a little bit about opportunity cost. Okay, so we talked about earlier, all right, how when we go, let me just relabel these points again, A, B, C, D, and E, okay, and let me just take away this over here. All right, I'm having a little bit of technical difficulty here, so we'll just let point F be. Okay, so from point A to point B, okay, we are trading off 125,000 guns for 250,000 pounds of butter. Okay, so you can easily say that for every pound of butter you gain, you are trading off half a gun. Okay. And vice versa, for every gun that you gain, you are trading off 2 pounds of butter. Okay, this is the opportunity cost we have. We said earlier that it was 10 pounds of butter or 5 guns with each labor hour. Okay, so with every gun that you produce, okay, you are giving up 2 pounds of butter, or for every pound of butter that you are producing, okay, you are giving up about half a gun. Okay. Okay, and one other concept I would like to go over is that of economic growth. Okay, so if, let's say we had a technological advance and we either, or basically we could produce more guns and more butter with each labor hour, or maybe we just have some immigration going on and we have more labor hours, so we can actually produce more combinations of butter and guns. This would shift the production possibility frontier outward. Okay, and it'll be shown like this. Or it could be the other case where, let's say we have immigration, people are leaving the country, so we have less labor hours, or we have some kind of natural disaster that affects our resources. We don't have as good machines, so we can't produce as much guns or butter. This would shift the production possibility frontier to inward, to the left. Okay, so outward would show economic growth. Okay, inward would show economic decline. Also, one last point I would like to add is, since in this case a production possibility frontier is a straight line, that means that opportunity cost is constant. Okay, so basically from points A to B to C to D to E, you're always trading off the same amount of guns for butter, and then vice versa. From E to C, from E to D to C to B to A, you're trading off the same amount of butter for guns. Okay, this basically implies that all your workers have the same opportunity cost. Basically, all your workers have the same productivity level, exactly the same. Each worker takes 10 hours to produce takes 1 hour to produce 10 pounds of butter, and takes 1 hour to produce 5 guns. Okay. Now, in reality, okay, workers all have different talents and different skill levels, so most likely, okay, they're not all going to produce the same amount of guns or butter in 1 hour. Okay, so let's look at a different example here, a little bit nicer, cupcakes and cookies. Okay, so All right, we have where we can use all our hours towards cookies and make 100 cookies, 0 cupcakes. I'll go all the way down where we make 100 cupcakes and 0 cookies, and we trade off at a different amount. Okay, so what we see here is a production possibility frontier is bowed outward. Okay, and every time we see a production possibility frontier that's bowed outward, that means there's increasing opportunity cost. Okay, so essentially, as we go from point A to point B to point C to point D to point E, okay, we give up more and more cookies to get cupcakes. So when we go from point A to point B, okay, you see that we only give up 5 cookies in order to gain 25 cupcakes. Okay, but when we go from point B to point C, we give up 20 cookies to gain another 25 cupcakes. From point C to point D, we give up 30 cookies to gain another 25 cupcakes. And then from point D to E, we give up 45 cookies in order to gain the last 25 cupcakes. Okay, and this basically shows that workers have different skills. So for example, okay, at point A, all workers are making cookies. If we want to go from point A to point B, the workers that are going to stop making cookies are the ones that aren't very good at making cookies and are probably better at making cupcakes. So since these workers weren't that great at making cookies anyways, okay, they're going to not give up so many cookies. When we go from point B to point C, these workers were a little bit better at making cookies. They probably are better at making cupcakes. But we still lose a little bit more cookies because these workers were a little bit more skilled at making cookies. Okay, but by the time we go to point D to point E, okay, these workers were probably really good at making cookies, but let's say for whatever reason, no one wants cookies anymore. Okay, they only want cupcakes. So these workers give up 45 cookies because they were really good at making cookies in order to make the additional 25 cupcakes over here. Okay, and this probably paints a more realistic picture of workers' skills. Okay, so the workers that are first to leave an industry are the ones that weren't very good at that industry to begin with, so they're not losing a lot. But as we lose more and more workers for another industry, then the workers that were best at the original industry are the ones who are giving up a lot in the original industry.